Hello everyone, in today's video we are discussing about the conversion of epsilon NFA to DFA. So we have got the epsilon NFA diagram. Now we need to, similarly like NFA, we need to draw epsilon NFA transition table. So let me draw epsilon table transition diagram. So similarly like NFA, we will be having inputs. For transition table we will be having inputs A, B, C, because we have A input, B input, C input. Okay, next input will be epsilon. Even this epsilon is taken as a input. When we have solved some epsilon problem, you would have seen that epsilon is one more input. Okay, and we have state Q0, Q1 and Q2. Q2 is a accepting state, Q0 is a start state. See here, Q0 is a start state, Q2 is a accepting state. Next we will be seeing Q0 on A, where it is going to Q0. Q0 on B, it is going nowhere, so we will say phi. Q0 on C, it is not going anywhere, so we will say phi. Q0 on epsilon, it is going to Q1. Okay, next Q1 on A, where it is going, it is not going anywhere, so phi. Q1 on B, where it is going, it is not going anywhere, so we'll say Q1. So Q1 on B, it is going to Q1. Q1 on C, it is going to phi. Q1 on epsilon, it is going to Q2. Q2 on A, it is not going anywhere. Q2 on B, it is not going anywhere. Q2 on C, it is going to itself. So Q2 on C, it is going to Q2. And epsilon, it is not going anywhere, no epsilon transition, so phi. So this is our transition table for epsilon NFA. Next we need to write E closure. So we will be finding E closure. We need to find epsilon closure. So epsilon closure on Q0, where it is going? See here, epsilon closure of Q0, from Q0 it is starting epsilon, so it is going to Q1, and also Q1 is sending that epsilon to Q2. So we can say that epsilon closure on Q0 is having Q0, Q1, Q2, because from Q0 epsilon is sending to Q1, Q1 to Q2. Okay, next we need to find epsilon closure of Q1. So we need to see from Q1 where the epsilon is starting. So first it will start from Q1 and that epsilon is sending to Q2. So we will take Q1, Q2. So Q1, Q2. Epsilon closure of Q2. So epsilon closure on Q2, where it is going? It is accepting from Q1, but it is not going anywhere. So we can say we have only, see in this diagram, it is accepting epsilon closure from Q1, but it is not sending any epsilon closure from its. So we can say epsilon closure of Q2 is Q2 only. Okay. Next, by seeing this, we can draw DFA table. By seeing this, how we can draw? See, our first step is we need to find delta transition of Q0, Q1, Q2. Okay, how this Q1, Q2 will come, I will explain. Okay, I will explain this how it is coming. So this will come. So we know that our DFA table, we will take this as a start state, Q0, Q0, Q1, Q2, Q0, Q1, Q2. is our start state, because Q0 is present. Whenever Q0 is present, we will say it is a start state, and also it is a final state, because in this figure we have got that Q2 is a final state. So we have input A, B, C. Okay. So how we will find value for Q0, Q1, Q2? I will show with an example. So we will be finding value of this by using this transition formula. So for A input, how we will be solving? So we will be solving delta of Q0, Q1, Q2, comma A. So what is the transition of Q0 on A, Q1 on A, Q2 on A? So we can see that Q0 on A, so Q0 on A, union of delta transition of Q1 on A, union of delta transition of Q2 on A. So Q0 on A, where it is going to Q0, union Q1 on A, it is going to 5, Q2 on A, it is going to 5. So we have got Q0 value. So we can say this is the E closure of Q0. So what is, we can say this is the epsilon closure of Q0. So epsilon closure of Q0 is Q0, Q1, Q2. So here we can say epsilon closure of Q0 is Q0, Q1, Q2. Similarly, we have to find for B and C. So delta transition of Q0, Q1, Q2 on B. So what the value we will get? Q0 on B is 5, union Q1 on B is Q1, Q2 on B is 5, union 5. So Q1 we will get. So epsilon closure of Q1 is, so your epsilon closure on Q1 is Q1 comma Q2. Okay. So we will say it is Q1 comma Q2. So here we can say on A it is going to Q0, Q1, Q2. On B it is going to Q0, Q1. On B it is going to Q1, Q2. And similarly we need to find delta transition for Q0, Q1, Q2 on C. So here we will get on C it is going to Q0 on, see this table you need to see, Q0 on C it is going to 5, Q1 on C it is going to 5, Q2 on C it is going to Q2 itself, union of Q2. So here we can say E closure of Q2. E closure of Q2 is nothing but Q2. So Q2. Okay. So here the next value which is here in this table is Q1, Q2. So we can say here Q1 comma Q2 is our next value. So Q1 on A, where it is going 5. Q2 on where it is going nowhere. So 5. Q1, Q2 on B. So it is going to Q1. So Q2 on B it is going to 5. So E closure of Q1 is nothing but it is going to Q1, Q2. And Q1, Q2 on C, where it is going? It is going to Q2. Okay. So Q2 of epsilon closure is Q2 itself. So next we have Q2, and here also Q2 is present, so we will make final state, and this is also Q2 is present, so this one also we will make final state. Q2 on A, it is going to nowhere. Q1 on B, it is going to Q2 on B, it is going to nowhere. Q2 on C, it is going to Q2 itself. Okay. So we'll solve this problem. We'll draw this diagram. So here we will get a state diagram of. So here we can draw the state diagrams as Q0, Q1, Q2 has a single state we can take because it is a DFA table and it is a final value. So it is a final value, we will take it as a single state. Then we have next state Q1, Q2, Q1, Q2, and next we have Q2, and both are final state. Q0, Q1, Q2 on 8 is going to itself. Q0, Q1, Q2 on B, it is going to Q1, Q2. Q0, Q1, Q2 on C, it is going to Q2. Q0, Q1 on 8 is not going anywhere. Q1, Q2 on B, it is going to so where it is going on B, it is going to itself. Q1, Q2 on C, it is going to Q2. Q2 on C, it is going to Q2. So this is the final DFA.